Hello, 8th graders. This is Mrs. Mooney. We are in Unit 5, Properties of Exponents. And today we're starting Lesson 20, which is all about zero and negative exponents. Our learning target is discover the rules of zero and negative exponents and use these two new rules to simplify exponential expressions. So let's get started. What do we do when we have a number or an expression raised to the zero power? So I want to use this example to illustrate why everything raised to the zero power is actually equal to 1, which I know you guys already know. All right? So let's start with 3 to the 4. 3 to the 4 is 3 times 3 times 3 times 3. 3 used as a factor 4 times, and that's actually equal to 81. 3 to the third power is 3 copies of 3, and that's equal to 27. 3 times 3 is equal to 9, times another 3 is equal to 27. 3 squared is equal to 9, and 3 to the 1 we know is just 1 copy of 3. That's just equal to 3. So how do we get to 3 to the 0? So I want you to think about, well, what pattern is happening here? As I go down in my exponents, as I go down by 1 exponent, what's happening to my evaluated expression? When I go from 3 to the 4th to 3 to the 3, I divided 81 by 3. When I went from 3 to the 3 to 3 to the 2, I divided the previous expression, 27, I divided it by 3 and got 9. When I divided 9 by 3, I got 3. So if we repeat this pattern, if I divide 3 by 3, I'm going to get 1. So 3 to the 0 must equal 1. And in fact, any number, we could repeat this with anything as the base, and we would see that this pattern holds no matter what number is the base. Any number raised to the 0 power is just going to be equal to 1. So this is a new rule. X to the 0 power is equal to 1. And this is just a general form of the idea. It means that anything raised to the 0 power is going to be equal to 1, except 0. Any non-zero number raised to the 0 power will be equal to 1. So let's try this rule out. So give this a shot. Pause the video and see if you can come up with what each of these expressions will equal. Be careful, there's one that's really tricky in there. Okay, so when we raise 7 to the 0 power, we're going to get 1. When we raise pi to the 0 power, we're going to get 1. This one's the tricky one. What is the base? Are we raising all of -2 to the 0 power? Think about what is the exponent touching? It's only touching the 2. So this could be rewritten as -1 and 2 is being raised to the 0 power. So it's -1 times 2 to the 0 power. Well, 2 to the 0 power is equal to 1 because of our new rule. But then I have to multiply it by -1. So this is actually all equal to -1. A little bit different is this -4 raised to the 0 power. What is the exponent touching? It's touching everything inside these parentheses, or it's touching the parentheses, so everything inside the parentheses gets a power of 0. So that negative and that 4. So this one would be equal to 1. And let's get this out of the way. And the same thing with this last expression. The 0 is touching the parentheses, so everything inside parentheses gets the power of 0. Therefore, this entire expression would evaluate to 1. So the rule is kind of simple, except for when we get to these guys here. So let's look at this a little bit more closely on the next slide. So a helpful hint. If you have a negative term written in expanded form, it's going to help you when you simplify powers. So for example, if I have -3 to the 2nd power, I should rewrite it as -1 times 3 to the 2nd power. right? That exponent of 2 is really only touching the 3 and not touching this -1. So this will evaluate to, oh, I didn't write it out. So this, the 3 to the 2 is going to evaluate to be 9, but then I still have to multiply it times -1. So I'm going to get -9. If that -3 had been in parentheses, that would tell me to square everything in parentheses or use -3 as my base. -3 times -3 is equal to +9. Do you see the difference? If the negative is inside the parentheses and it's all squared, we're using the entire number, including the negative, as the base. But if not, we're only squaring or raising to an exponent what the exponent is touching. Let's get rid of this. So same thing if you have a variable. If you have -x squared, you should rewrite that in expanded form as -1 times x squared. And that will really help you decide if your answer is going to be positive or negative. So in this case, this would evaluate to -x squared. So now you know what to do if you have a negative number as a base. Just be careful and expand it out. All right, let's take a peek at our next slide. So what about when we have negative exponents? We haven't seen this at all. I'm going to use a similar example to help illustrate why the rule of negative exponents actually works. So let's think about what is 2 to the 4? Well, 2 to the 4, if we expanded that out, would be 4 copies of 2. So 2, times 2, times 2, times 2. So that's 4 times 2 is 8, times 2 is 16, right? So 2 to the 4 is 16. 2 to the 3 is 8, 2 to the 2 is 4, 2 to the 1 is 2, and using our new rule, we know that 2 to the 0 is just 1. So this pattern is just going to keep repeating even into the negative numbers. So remember what the pattern is. If I go from 16 to 8, I divided by 2. Let's clear that out. If I went from 8 to 4, I divided by 2. As my exponents are going down, I'm dividing my answer by the base. So I'm dividing by 2. If I divide 2 by 2, I get 1. This is how we discovered the rule of 0 exponents. And this is how we're going to continue the pattern to discover the rule of negative exponents. So what would happen if I took this 1, if I took this 1 and continued to divide it by 2? 1 divided by 2 is just equal to 1 over 2, or 1/2. Let's clean this up. And if I divided 1/2 by 2, I would get 1/4. And I'm going to continue this pattern. I want you to make sure you write this down in your note sheet. Your note sheet has this exact same example. Now I want you to think about, look at what you wrote down on your note sheet for those powers of 2 as we went into the negative exponents. What are you noticing? You might talk to a partner right now about what you're noticing about these negative exponents compared to their positive exponent counterparts. So what's the same and different about 2 to the positive 2 and 2 to the negative 2? Also look at 2 to the 3 and 2 to the negative 3. Can you see what's happening? Pause the video and talk to your partner. What you might have noticed is that 2 to the 2 is equal to 4, and 2 to the negative 2 is equal to 1 over 4. Interesting. You might have also noticed that 2 to the 3 is equal to 8, and 2 to the negative 3 is equal to 1 over 8. It seems like we have some information here to come up with a rule for negative exponents. So let's look at what the rule is. All right. So negative exponents. If you have a to the negative n, whoops, I need my marker again. A to the negative n is just the reciprocal of a to the n, right? So a to the negative n is equal to 1 over a to the positive n. I want you to be really careful here with negative exponents because a to the negative n never ever means negative a to the n. That is not true. All that negative exponent means is instead of repeatedly multiplying a by itself, I want you to repeatedly divide or put in the denominator that many copies of a. All right. It never ever makes your answer negative or positive. It never changes the sign of your answer. It only means to repeatedly divide. And the rule also works in reverse. So if I have a to the, whoops. So if I have a 1 over a to the negative n, I have a to the positive n in the numerator. So they are each other's reciprocal. A to the negative n is the reciprocal of a to the n, and 1 over a to the negative n. So they're just reciprocals of each other. If I have a to the negative n, that is the reciprocal of a to the positive n. It's 1 over a to the positive n. And if I have 1 over a to the negative n, that's equal to a to the positive n. So really what we're doing here, let's get a new color. Really what we're doing here is if I have a negative exponent, I make it positive and move it to the opposite of where it is. If it's in the numerator, it's a mover and it goes down to the denominator. If it's a negative exponent and it's already in the denominator, it's a mover. It goes up to the numerator so that I have a to the positive n in the numerator. Okay, so we know why it works and we know the little shortcut method. If it's a negative exponent, it's a mover. So let's try some examples here. Quick examples. All right, we have x to the negative 3. Because I have a negative exponent, that means this guy's a mover. It's currently in the numerator, so it's going to go in the denominator as a positive exponent. 1 over x to the positive 3. Same thing here. 4 to the negative 2 has a negative exponent, so it's a mover. It's going to go into the denominator since it started out in the numerator. Whoops, so now I have 4 to the positive 2. Let's try some more examples. Let's clear this up. What if we have, whoops. Okay, so there are our answers again. All right, so what if we start out with negative exponents already in the denominator? Well, we know that that means if it's got a negative exponent, if it's got a negative exponent, it's a mover. This guy started off in the denominator, so I need to move him up to the numerator, and I need to make it positive when I do that. So this becomes x to the 7. You could say x to the 7 over 1, but that part isn't necessary, so it's just x to the 7. Same thing here. We've got 3 to the negative 3 already in the denominator, so it needs to move up to the numerator as a positive exponent. So that's going to give me 3, whoops, where's my answer? 3 to the positive 3 in the numerator. All right, so these are the rules that we just used. That say, if you have a negative exponent, you just take the reciprocal and make the exponent positive. So let's put that into action here. Let's try some examples. So I want you to pause the video, try these 3 examples and then unpause the video and see how you did. All right, let's take a look. So I have 2 to the negative 2. A negative exponent says to repeatedly divide by my base, or said another way, it's a mover. So it's in the numerator right now, so it needs to go in the denominator as a positive exponent. So I'd have 1 over 2 squared, or 1 over 4. All right, part 1b. I have a mover again, a negative exponent, so it needs to go into the numerator, and it needs to become a positive exponent. So that's going to be 2 squared in the numerator, or positive 4. All right, and number 2, I have a mover because it has a negative exponent. But be careful, this y squared has a positive exponent. So where it is where it belongs. We're not going to touch y squared. It's going to stay where it is. But this 5 to the negative 3 says repeatedly divide by 5 3 times. So that means it goes into the denominator with the y squared. So we will have 1 over 5 cubed times y squared. And we can simplify that because 5 times 5 is 25, and 25 times 5 is 125. So we have 1 over 125 y squared. All right, we do have a couple more examples, so let's go to the next slide. I want you to pause the video, give these a try, and then come on back. Okay, in example 3, we actually have 2 movers. We've got x to the negative 1. That has to go into the denominator. And we have y to the negative 3 already in the denominator, so that needs to go to the numerator. So we're really just going to flip this fraction on its head. So we're going to have y to the positive 3 in the numerator, and we're going to have x to the positive 1, or just x, in the denominator. And that's all we can do right now. Okay, when we start getting into expressions with coefficients, it's a little bit trickier. But once you do a few of these, it's no problem at all. So we have a mover in the numerator. That's x to the negative 2. The 5 is just to the first power, the positive first power. The 5 is not a mover. He stays exactly where he is. Same thing in the denominator. We have a negative 10. That's just raised to the power of positive 1, so he stays where he is. Be careful, that negative 10, sometimes we want to over-apply the new rules that we've learned. That has nothing to do with an exponent. It's just the number negative 10. It doesn't mean it moves. But we do have a z to the negative 5, and that means that needs to go to the numerator, and this x to the negative 2 needs to come down to the denominator. So let's figure out what stays first. So the 5 and the negative 10 stay exactly where they are. Let's start rewriting our fraction. So we've got negative 10 in the denominator. All right, this x to the negative 2 we decided needs to move. He needs to go in the denominator. And the z to the negative 5 is also a mover. He's in the denominator, so he needs to go up to the numerator. So z to the positive 5. Now, you might think that we're done, but we've got a little bit more simplifying here. So if we just had the fraction 5 over negative 10, we know that we can represent that as negative 1/2. So we actually have the fraction, a negative fraction, negative 1 over 2. And the z to the 5 stays, and the x squared stays where it is. So that is kind of messy. So we've got z to the 5 over 2. We have z to the 5 in the numerator. And we have 2x squared in the denominator. And the entire fraction is negative. All right, I want to try 3 more examples that are a little bit more challenging. So let's take a peek at the next slide here. All right, so pause the video and come back when you're ready to check your work. Okay, so let's take a look at number 5. Number 5, I have negative 2, not a mover. I have x to the 3, that's a mover. y stays, and z to the negative 2, that's a mover. So those two that I circled need to go down to the denominator as positive exponents because we're repeatedly dividing by these numbers. All right, so that's our final answer for number 5. No more simplifying. Let's look at number 6. I'm going to circle my movers. That's a mover because of the negative exponent. That's a mover because of the negative exponent. And d to the 0, well, that's just equal to 1. That doesn't change the value of my expression at all. So I'm going to cross that out. So negative a stays exactly where it is in the numerator. And the 2 that I circled have to move to the denominator as positive exponents. So that's our final expression. You could rewrite this as, since we have a negative in the numerator and a positive denominator, the fraction itself is negative. So it's negative a over b squared c cubed. All right, and finally we have number 7. So remember what I said about negative bases. That negative w to the negative 2 is actually negative 1 times w to the negative 2. So the negative 1 stays exactly where it is, all right? So let me erase that. So I have a w to the negative 2 that's a mover, and a z to the 0 that doesn't change the value of the expression because it's just equal to 1. So I have a negative 1 in the numerator, that stays. I have a c in the numerator, that stays. I have an x cubed in the numerator and a y, and those all stay because they have positive exponents. The only thing that moves is that w to the negative 2, and it comes down as w to the positive 2. So that c kind of looks weird. That's a c. All right, so to fully simplify this, since I have a negative over a positive, my entire fraction is negative, and I have c x cubed y over w squared. And that's it. Beautiful, isn't it? So what I would like to do now is let's summarize these 2 new rules that we learned. So I want you to grab your flip books, and I want to write the rules for 0 and negative exponents. I want you to do the examples behind those doors. And then if you want to color the doors, now that we're finished with our foldable, if you want to color code the doors, if that helps you, that would be great. And make sure your name is on the back, because remember, we're using these flip books for our next quiz, and you want to make sure that you have yours. All right, turning to our flip books. So the first rule we learned is 0 exponents, so I'm going to click on that. And as you recall, the rule of 0 exponents is that anything raised to the 0 power is just equal to 1. So that's the rule. X to the 0 equals 1. Pause the video and do these examples, and then come on back. All right, these were really easy examples. I didn't even put any negative bases in here for you. So we've got x to the 0 is 1, f to the 0 is 1, w to the 0 is 1, and I want to add another one. Let's do example number 4. What if I had negative w to the 0? Remember, we would expand that out. Well, the 0 is only touching the w, not the negative 1 that's multiplied times the w. So we'd expand this out like this. Negative 1 times w to the 0. So that's negative 1 times 1, right? That would be equal to negative 1. All right, moving on. Our second rule that we learned is for negative exponents. So let's open up the window for negative exponents. Remember, the rule here is if I have a negative exponent, I take the reciprocal of this. So that is 1 over x to the positive m. Pause the video and do these examples and come on back. Okay, so x to the negative 4, that's a mover. I need to put that in the denominator as x to the positive 4. Repeatedly divide by x 4 times. Same thing with n to the negative 2. Take the reciprocal. That's 1 over n to the positive 2. Remember, when you move the exponent, you must take away that negative sign. It is not 1 over n to the negative 2. And finally, a to the negative 7 is 1 over a to the positive 7. All right, I want to do another example on this one too, because they didn't quite give you enough. So let's take number 3 and switch it up a little bit. Okay, so example number 4. What if they had given you 1 over a to the negative 7? All right, so you'd say to yourself, hey, this guy is a mover because he has a negative exponent, so he has to go up to the numerator. So that would become a to the positive 7 in the numerator, right? That's really over 1, but you don't need to write over 1. Okay, we're making some progress here. The next thing, let's erase this and move on to the next slide. The next thing that I would like you to do is to practice these 2 new rules. Keep your foldable out so that you can remember how to do these new rules or how to apply these new rules. I want everyone to start on the beginner maze. And if you get through that quickly and you think you're hot stuff, I want you to go from the bunny slope to the intermediate slope and try this maze. It's quite a bit more challenging. All right, the answer keys will be posted in Google Classroom. Make sure you check and correct your work. Make sure you understand why the correct answer is the correct answer. And if you still don't understand, ask a question of a partner or of your teacher. That is it for today, and I will see you guys in class.